Hi guys, so we'll be solving an O-level past paper question from the year 2015. The session is October-November. This is question number 9. We'll draw the graph of a function, use a tangent to find the gradient, and solve a cubic equation. So let's start. The question says the distance d meters of a moving object from an observer after t minutes is given by this equation, d equal to t squared plus 48 over t minus 20. Part A says some values of t and d are given in the table. The values of d are given to the nearest whole number where appropriate. This is the table that they're talking about. It says complete the table. So we have to find this value of d for this value of t. How do we do that? We plug this value of t into this equation. 7 squared is 49 plus 48 over 7 minus 20. This gives us 35.8. If we round this off, we get 36. Okay, let's remove all the other marks. So it's a neat and clean question. The next part says, on the grid, plot the points given in the table and join them with a smooth curve. Okay, so the first point 1 and 29 is supposed to be over here. The next point 1.5 and 14. 1.5, 1, 2, 3, 4, 5. Okay, and you go 14 up. 1, 2, 3, 4. It is supposed to be over here. The next point is 2 and 8. 2 and 8 is supposed to be here. The next point is 2.5 and 5. 2.5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is supposed to be here. The next point is 3 and 5. 3 and 5 is supposed to be over here. The next point is 3.5 and 6. 3.5, 1, 2, 3, 4, 5 and 6 is supposed to be here. The next point is 4 and 8. 4 and 8 is supposed to be on this point right here. Then it's 4.5 and 11. 4.5 and 11. 1, 2, 3, 4, 5 and then 10 here and then 11 over here. Okay, the next point is 5 and 15. 1 second, 5. Okay, what's happening? Okay, 5 and 15, let's do it. So 11, 12, 13, 14, 15, it is supposed to be over here. The next point is 6 and 24. 6 and 24, that's a tricky one. So 1, 2, 3, 4, it is supposed to be over here. And the last point is 7 and 36. 7 is on the last one. 1, 2, 3, 4, 5, 6. It is supposed to be over here. Let's connect these points through a smooth curve as they have asked us to do. So I'll try my best. So we go from this point all the way to this point. Okay, that's not smooth enough. I'm going to redo this because the start was not good. So it is supposed to be going like this. And it curves like this. And then it curves like this. Okay, still it's not smooth enough. Let's do the last bit once again. So it goes like this. Okay, now this is better. The next part says, by drawing a tangent, calculate the gradient of the curve where t is equal to 4. Let's do this in blue color. So this is done in blue color. How do we do this? First of all, let's take out our scale. It says where x is equal to 4. That means where t is equal to 4 over here. We draw a tangent that is going to give us a nice and fine value of the gradient. Okay, so the tangent would go like this. One of the values is this right here. The coordinates of this value are 2.5 and 0. Let's talk about the other value over here. The coordinates of this value are 7.5 and let's see what it is. 27. 2.7. No, 27. Sorry, not 2.7. It's 27. 27. Okay, so how do we find the gradient? We do 27 minus 0 divided by 7.5 minus 2.5. Let's see what we get. 27 divided by 7.5 minus 2.5. This gives us 5.4 as the gradient. So we write it over here, 5.4. The next part says, explain what this gradient represents. Since this is a distance and time graph, the gradient represents the speed. Let's do the remaining parts in red. The next part says, for how long is the object less than 10 meters from the observer? So less than 10 meters means you have to draw a horizontal line over here at 10 like this, and then use the same horizontal line to find the points of intersection of the curve and this straight line. One of them is over here, the other one is going to be over here. Okay, So the first value of t is going to be 1.8. So it is 1.8, and the last value of t is going to be 4.3. So you do 4.3 minus 1.8. Let's see what we get. 4.3 minus 1, oh, one second, 4.3 minus 1.8, our value comes out to be 2.5. So we write it over here, it is 2.5 minutes. Okay, the next part says, using a graph, write down two values of t when the object is 12 meters from the observer. For each value of t, state whether the object is moving towards or away from the observer. So t needs to be, sorry, the distance need to be 12 meters. So let's draw a line at 12, a horizontal line at 12. So let's do this in green perhaps. So if we draw a horizontal line at 12, it means we draw a line over here, and then we connect the points of intersection of this line like this. One second, one of them is going to be over here. Let me remove this mark first. Okay, and the other point of intersection of the graph and this line is going to be, oh, what am I doing? Over here. Okay, so the first value is, what is the first value? 1, 2, 3, 4, 5, 6, 1.65. Let's use this, 1.65. And the other value is 1, 2, 3, 4, 5, 6, 4.6. So when t is 1.65, since it is coming closer to the observer, the object is moving towards the observer when the value is 1.65, and when the value is 4.6, the object is moving away from the observer. Okay, let's move on. The next part says, write down the equation that gives the values of t when the object is 12 meters from the observer. So the equation that we need to write down, first of all, the equation of the curve is t square plus 48 over t minus 20. Since they're talking about 12 meters, d is supposed to be 12 over here. That means this equation is equal to 12. We can also simplify this. We can write this as t can be the common denominator. This becomes t cubed plus 48 minus 20t, and d goes to the other side, gets multiplied by 12. So this becomes t cubed plus 48 minus 20t equal to 12t. This is just, I'm just writing this stuff to make it simpler. Otherwise, we can also use this equation right here. So your final equation can become t cubed minus 20t minus 12t plus 48 equal to 0, which can be condensed to t cubed minus 32t plus 48 equal to 0. So we write it over here, t cubed minus 32t plus 48 equal to 0. This is your answer, or you can use this as your answer as well. Okay, the last part says, find this, this equation is equivalent to t cubed plus at plus 48 equal to 0. This is the simplest question so far that we've done in this is the simplest part. So t cubed minus 32t plus 48 equal to 0, or in other words, this can be equal to the other equation given in this question right here, which is t cubed plus at plus 48, which is equal to 0. So t cubed and t cubed are the same. They can cancel each other out. 48 and 48 can cancel each other out. So you're left with negative 32t equal to at. And if you cancel the t's out over here as well, the value of a comes out to be negative 32. So your answer over here is negative 32, and we're done with the question. I hope this question made sense. The complete working of the entire question is present in the description below for you to download. If you like this video, hit the subscribe button, and thank you so much for watching.